Hello, everyone. Welcome to the third episode of Cognite AI Office Hours webinar series. My name is Vibha Srinivasan. I'm VP AI Engineering at Cognite. So, in the past two episodes, we discussed the basics of industrial AI agents, what they are, why your organization needs them, and what do you need to implement them effectively in your organization. So, in the last episode specifically, my colleague Milad spoke about what are the ingredients of an industrial AI agent. He focused on aspects such as the data sources for these agents, the industrial knowledge graph, techniques such as context augmented generation, and the aspect of access control. So, in today's episode, I will be focusing on language models. So, what are language models? These are one of the main ingredients of industrial AI agents. These are basically models designed to understand and generate human language. So, a language model is essentially trained on vast amounts of text data, and they use techniques to infer what, like the next word in the sequence, is going to be based on the context that has been given to them, and that is how they generate, human language. So when it comes to like choosing what language model to use for your industrial agent, then we need to first talk about what are the different kinds of models out there, how these are categorized, what their advantages and disadvantages are, and what some specific examples might be of their use cases in industry. So broadly, we can talk of three categories of models: large language models, LLMs, small language models, SLMs, and then custom models. So let's go one by one. Large language models, LLMs, of course, very popular. These are essentially trained on vast amounts of data, all of the internet data out there. And when we say large, we are saying they typically have hundreds of billions of parameters. And as a result, they are highly general purpose. They are very versatile, and their ability to recognize, like understand human language and then reason and then generate human language is at a very advanced level. So typically, these are used, like I said, because they are general purpose, they can be put to use where you need that versatility. So for an example of that would be like anytime you have a large number of documents that need to be summarized, that need to be translated, you have to answer questions based on a large number of documents. So these are all examples where you could use LLMs. And other examples are where, like I said again, because they're versatile, they are good at doing like few shot or zero shot learning, which means, you don't need to do any task specific training or fine tuning typically. You can sometimes just give it a few examples of, if this is the case, this is how it should be, some kind of guidelines like that. And even with that, the LLM is able to perform very well with the task that is put forth to it. So some examples in a heavy asset industry could be, let's say in R&D work, there is a lot of scientific literature that needs to be analyzed. There are any number of papers, documents from which you have to gather trends and insights, and then put all that together to come up with some kind of a recommendation. So that could be like one application for an LLM. Another one that comes to mind is something in like the area of compliance, where again, these are like really complex documents. You need to identify what portions are relevant, what portions are most important, what is applicable in which scenario. So again, parsing all that text and summarizing them, and understanding, like, recognizing certain entities in them. So those are, that is one use case where an LLM could be very effective. Another example that comes to mind is, of course, like a customer support situation where like you can have many different types of queries coming from the customers. It's about their materials that are being used, about safety protocols, about environmental implications, and so on, or like, questions about vendors, processes, sources, etc. So that kind of, where that kind of versatility is needed, that's another place where an LLM would be suitable. So in terms of disadvantages, then clearly these require like a very high amount of computational resources to like maintain them, to run them, and so they are not suitable when you are constrained. When you're in a resource constrained situation, then these would not be applicable. Another issue is when you have like very specific tasks that need to be performed that require you to, have some more knowledge of the domain. Then these, because of their generic nature, would probably not perform as well in those situations. So now we come to the next category, which are small language models. And these are lightweight models. We are talking of a few million parameters for these models. So these are definitely less computationally expensive, to whether to train or to, to maintain, to deploy and so on. And therefore they're also, but they're very quick when it comes to inference. So which is like when they are actually running, then the speed at which they can perform, at which they can respond, is typically higher than we see for LLMs. So again, where could these be used? So these are lightweight and they're very specific for certain tasks. So one example could be like keyword extraction. So let's say you have specific kinds of like material data sheets or SDS, safety data sheets, and those need, you need to identify certain key terms in there. Some information pertaining to, say, storage of chemicals. So that kind of keyword detection or document classification, those kinds of specific tasks, you can use an SLM for. You can use them for like a simple kind of a chatbot, which is answering, within a narrow scope of queries. Let's say employee queries about certain policies in the workplace. So, something which is like very specific, it has a narrow scope. There, an SLM can be put to use. Another very good use case for this, especially in heavy asset industries, are these can be deployed in like real-time systems, or like basically areas of your like facility where there would be limited internet access. So these can run on edge devices. So that is one very good application of SLMs, especially like in the industrial context. So now we come with that to custom models. And custom models, typically you are starting with like an open source model, and then those are getting trained on some very domain specific data. These would really do well in situations where that like very key domain knowledge is needed. So an example for that could be, let's say, in like patent analysis, where you have these applications and you need to extract certain kinds of information from them, like chemical structures, or like reaction mechanisms, things like that. So there, you could take a custom model which has been trained on that kind of data. So again, just to emphasize, these need to be trained on domain specific data sets. But that kind of patent analysis could be a good example where this is used. Another example could be like when you are dealing with financial documents or say legal documents. You could train a custom model to interpret and analyze these kinds of documents, and then generate content or generate like insights for that specific use case. You could like also do things like, when you have logs coming out of equipments or like other logging systems, and these need to be summarized and then put into, like, based on that you want to create like a operating guideline or like troubleshooting procedures for that specific process, let's say. So again, you can train a custom model on this kind of data for that task, and that's one where it would perform very well. So again, these are like medium-sized, typically, these models. In terms of disadvantages, they are not general purpose again, and it does take some time, and it takes a subject matter expertise to identify what are the relevant data sources for training for this use case. So those are some of the things to be aware of. I wouldn't say limitation, but things to be aware of when you decide to go with a custom data model. But they can perform well in like those kinds of domain-specific use cases. So we've covered like LLMs, SLMs, and then custom models. And then each, have their specialties, each have their like limitations. And, it really depends on your use case, your performance requirements, what kind of resource constraints you have, like where you want to deploy these use cases. All those go into, deciding which model to use. Now, you've put a language model, you've decided to go with something. The next question is now, how do you evaluate performance? How do you know how well it's performing? And so for this, there are broadly like two ways. One is, and both need to be put in place. One is offline evaluation and one is online evaluation. And offline evaluation is basically when, like, not with your actual agent, you've deployed it. You're not, when you're testing it before that. So you have, what do you need for that? You need like a good benchmark set of examples. So you have a data set, you say these are the expected scenarios, like these are like some example scenarios, like say questions, and this is my expected response in each of these examples. So that's your benchmarking data. And then you run your language model for like each of these examples, and you see how closely your response matches the expected response. And then you have different ways of generating that metric, or of like quantifying that the accuracy. And based on that, you can give a score for each of your language models, how well it did against your benchmark data set. And like I said, there are different ways of quantifying that, how well it matched the expected answer, whether it matters, whether it has to exactly match it, or like, is it like close enough? So there are ways you can compute similarity of like two pieces of text. There are also techniques like you could say whether like, it had certain components. So there are certain keywords that should have been present in the answer, or like even the format of the actual answer, whether it contained like these specific components which should have been there. So there are different ways you can quantify that, and based on that, you can come up with the score for any language model that you decide to try out. And this is something that you must do even before you decide to deploy your agent in production. To know whether it is, to have a way of quantifying, whether it is matching the, acceptance criteria for your organization to be able to use it. But as the thing is, data sets become stale, and when you are evaluating it, while actual users are using this solution that you've put out, this agent that you've put out, the kind of data you get, the kind of user interactions you get could be very different. And so that technique, that strategy is called like online evaluation. A simple example of online evaluation is the user giving explicit feedback, like a thumbs up, thumbs down on responses. And collecting that will give you a sense of, okay, this is how well this model is performing. And there are like I said, explicit ways of like the thumbs up, thumbs down, but there are also other things like when your agent is giving a certain suggestion, but the user decides to like modify the suggestion a bit. So an example could be like in code generation, your agent is recommending a certain piece of code is what you need to implement, but the actual end user then changes it a little bit and uses it, and that is information that you can capture from your product feature or however you've deployed this agent. And so that is, again, a very important thing to measure and to collect that information to know, how well your model is performing. There are also other like implicit ways you can implicit things you can measure. So for example, how often is the end user engaging with this agent? How long is their engagement? And again, it could be like in terms of duration, or it could be like repeated usage patterns, frequency with which they are using it, etc. So that is again a very important aspect to capture. So you need both. You need the offline evaluation strategies. You need the online evaluation also in place. And based on that, you can add things to it. You can do A/B testing. You can deploy different kinds of language models. You can see how one is performing versus another. And all this, help you understand, not just in terms of how accurate it is, but also how useful it is. There may be other aspects, such as the structure in which it is answering it, or how you've deployed the solution, which could impact like the feedback that you're getting. But basically, that is how you evaluate how well your model is performing. And I wanted to mention one more thing, that when we are talking about metrics and like quantifying how close something is to the expected answer, there are also like things you can do there to to add to that would be things like you occasionally sample these responses, and then you can use like a human in the loop kind of. You have a human validate whether that response is indeed accurate or not. So you do that for some percentage of your data set. You can also have a more like a more advanced language model kind of evaluate the responses of another language model, and so on. So there are different ways in which you can do this evaluation, but that is a key component to like putting an agent in practice and then measuring its performance. And then, okay, we've talked about evaluation strategies, and then now it comes to the final piece, which is, how do you then deploy these? How do you like orchestrate these in practice? And like I said, all of this, knowing what your use cases, what are your constraints are, what accuracy is desired, all that helps in narrowing down which model to select. Your evaluation techniques help you again compare one versus the other. But if you are not someone who's a AI engineer, there are also like other frameworks out there that can help you decide like which is the language model to go with for a specific task. So there is a framework called Auto LLM. So this is like a system or a framework which helps you, based on your use case, what is the task you're trying to accomplish? What are the data sources? Is it domain specific or not? So kind of understanding all of those use cases. Then, how easy it is to get access to those data sources. So again, this is all about, the use case itself. Then, understanding aspects such as, what is the performance that is desired? What are some cost constraints that you have? Are you looking to, manage costs within, within limits? And then if you have additional constraints, like, it needs to, be deployed on the edge. It is a place with like limited internet access. So those are all criteria that are used in place, to decide which is the optimal language model to go with for a specific task. So again, there are frameworks like auto LLM frameworks which are available, which make it easier for someone who's not a expert to go and put something like this in practice in their organization. I sound like I'm repeating myself, but it depends, of course, on your use case. For example, there are models that are better at analyzing, image data and like, sensor data and so on. There are models which are, suited better for like, geological kind of data analysis and so on. And so that is, of course, a very important criterion when it comes to, going with what is the model to go with. So just to summarize, you have to look at your use case, what your configuration needs are. So how do you want to deploy this, this AI agent? Is it in some application? Does it need to be integrated with another platform? Is it an API? I mean, all those, the configuration, the deployment needs need to be taken into account. Then what your resource and cost constraints are. So this is how, auto LLM makes it more accessible to people, makes industrial AI agents, accessible and like, efficient for organizations. And so we covered, the types of language models, how do you evaluate them, and what are some additional frameworks to help you decide what language model is best for your organization, for your specific use case. And so with that, I'm concluding this episode. I invite you all to join the next episode of this series, which is going to be by Jason Shern, where he's going to talk about putting it all together, industrial AI agents in practice. So, coming up with examples of, he's going to talk about some examples of like complex industrial applications, and like how, industrial AI agents can be put in practice for these specific applications. So thank you all for listening. And finally, I would like to say, if you want to learn more about how organizations across the world are enabling industrial AI, then we'll invite you to attend our Global Industrial Data and AI User Conference, Impact, which is being held in Houston, Texas, on October 14th and 15th, so not too far from now. And there you'll hear from top experts across like verticals, so oil and gas, manufacturing, utilities, and so on. And you'll hear from them about how they are bringing data and AI into their organizations, how they are enabling their more efficient industrial operations with data and AI. To review the session, you can see more at like cognite.ai or just scan the QR code that you see on screen. We are almost sold out. And so I, invite you all to go check it out as soon as you can. And I hope to meet you all there. Thank you very much for listening. Bye-bye.